M. Aripungan, Associate Professor in the Department of Communication Engineering. I will handle the paper Control System Engineering for the second year EC students. That the subject code is EC 8391 and regulation 2017. The main objectives of control system engineering is that the student will be able to learn the components and the representation of control system introduced, and then learn various methods for analyzing the control system, whether it is in time domain specification using time domain or otherwise frequency domain, and then you will analyze the control system, whether that the control system is stable or not. So that the stability will be measured in time response analysis as well as the frequency response analysis. That is the various topics. And then the another main objective is to learn the various approach for the state variable analysis. So your control system engineering paper has 5 units. That the first unit is system components and their representation. What is the control system components? What is the main terminology and what is the main basic structure? You must study those topics. And then what is the basic difference between a feedback system and feed-forward system? And then another main approach is transfer function approach. For a electrical and mechanical system, how you find the transfer function of the model? It is the model-based approach. You will find them using black diagram reduction. You will find the transfer function of the system, and then that is signal flow graph. Also, you will measure the transfer function of the model. You will find the model, and then the synchronous as well as the AC and DC servo system also studied in the first unit. Your second unit is basically only for analyzing the time response analysis. So you will find the difference between steady state and transient state. You will analyze the transient state response and steady state response, and then you will measure the performance of a standard first order as well as the second order systems. We will give you standard signals to any first order and second order, how the system is behaving. What is the transient response, and another one is the steady state response. You must do. And if you are adding a zero or adding a pole in a control system transfer function, what is the effect in the transient response as well as the steady state response? And another important thing, that the steady state constant as well as the steady state error constant, it may be studied in this unit. And then you will find the what is the type of the system, what is the type number of system you must study in this unit. And then your control system, your control, basically most of the industry they are using only PID controller. Okay, so for you will implement, what is the advantage if you are using the PL1 controller and P plus I controller and P plus I plus D control system in this unit. And the second unit we already discussed, it is a time response. For your third unit, it is fully a frequency response analysis. It is the performance specification of your frequency domain, your frequency response of your standard second order system, and then you will analyze the control system in frequency response point of view. It is a body plot, polar plot, Nyquist, and then design of compensators. What is our achievement? What is our needed? Okay, you will design a body plot. You will use the lead compensation as well as the lag compensation. So cascade lead and cascade lag, and then some occasion you will use both the lag and lead compensation. Fourth unit, it is the concept of the stability analysis of the control system. What is the main concept? It is the bounded input for bounded output. And then using Arrow-Thurey criterion, you will measure the stability of the system. Generally, the stability may be in 3 cases. One is stable system, marginally stable, and then unstable system. And root locus concept also measure the stability of the time domain. Sketching the root locus, what is the procedures? What is the name of the procedures for sketching a root locus and Nyquist stability criterion also to measure the stability. And the fifth unit, that the control system using state variable methods, state variable representation. We will what is the state variable models from the transfer function conversion of transfer functions, state variable models, solution of the state equation. What is the concept of the controllability and observability? It is the very important one. And stability of the linear systems. Equivalence between the transfer function and then state variable representing. How you put a state variable for that particular transfer function. State variable analysis and digital control system. You will design a digital control system using state. So we will start with the first unit. It is the control system. What are the specific objectives for your first unit? So if you are studying the first unit, what you should learn? That first one, explain the different types of control system. How the control system it may be classified. It is the popular classification. There are so many ways of classification for the control system. How it will be different. And then what is the basic difference between a feedback system and feed-forward system? What is the advantage if you go for a feed-forward, and what is the disadvantage if you go for a feed-forward? And then using the mechanical and electrical system, in most of the control system, we are defined only in transfer function format. So how you find the transfer function of the mechanical as well as the electrical systems? To find the overall system transfer function using block diagram reduction as well as the signal flow graph methods. So I will start the first unit, first topic. So what is control system? What is the need for a control system in general? So if you see then, if you have a system, for any system, there is one input is there and there is a output is there. What is input and what is output? The stimulus or excitation, it will be applied to a control system. It means from whether you are using the external source to produce the output. So we will give the stimulus or otherwise some excitation, it will be applied to a system, and then from an external source, it will produce the output that is called input. Okay, so then the actual response, what is obtained from your output? That is from the response, the actual response obtained from your system, it is called output. So input is you will give the excitation or stimulus to the system. So what is the output will be come out from your system response. So generally, a system means it is an arrangement of a combination of different physical components. It will be for system means there are the different physical components. It will be connected or related in such a manner so it is to form an entire unit to attain a certain objective. So you will put a components, so many components. Okay, so your final output is a certain objective. Control means to regulate or otherwise the direct or command a system so that you will get some desired objective. Combining above definition, system plus control, it is called control system. So it is a arrangement of different physical elements connected in such a manner so as to regulate or command itself to achieve a certain objective. What is the difference between a system and control system? You will see that what is the basic difference between a system and control system. So you will see that a system, if you give the input to the system and you will get a proper output. But in control system, if you are giving the input, you will get a desired output. But here, for a system, you don't expect the desired output, it may be or may not be. You will take an example, fan AC system. So generally we know then if you give the supply to any fan, we will get a airflow. That is the basic thing. Okay, we know that. First case, I will take then a fan without regulator. So there is no regulator that the supply is given to fan. You will get a output. That the output is a airflow. But you see then, but it cannot be a control system because it cannot provide a desired output. It is the controlled outflow. It is the airflow. It is not controlled. So it is not a control system. Okay, now you see that difference between here a fan without blade. Okay, without blade, it is not a system. Okay, you see that because it cannot provide any output. There is no output without blade. Okay, so it is not a system. So what is control system? A fan with regulator. A fan with regulator, you will get a desired output. What output if you want? What amount of airflow you will be expected from your fan? It is the controlled airflow. So it is the desired output. So that system means without regulator, in the fan it is a system, but with regulator, the fan is a control system. And then that is the main classification. The classification of control system. The control system may be classified in a number of ways. Here we are discussing some popular classification. First of all, that the classification of control system is basically depends on the method of analysis and design, whether it is a linear control system or otherwise non-linear control system. In control system engineering, we will only study about the linear control system. Okay, so what is the meaning of linear control system? It obeys the superposition theorem. The principle of superposition theorem includes two important properties. One is homogeneity and additivity. Homogeneity means a system it will be a homogeneous. It means if you multiply a input with some constant, you will get the same impact in your output. That the output should be multiple. What amount of input is multiple? A constant in the input, that the same amount it will be multiple in the output sector. Additivity means if you take a system, yes, I will give you the first time I will give you input A to the system and I will get a output B. After some time interval, I will give the same input A to the system, it is a second input, I will get a same output B. And then in third occasion, I will give the previous two inputs, it is A plus A, it is given to the system. If I got the output B plus B, that is I got previously, then that the system S is the additive. Another way of classification, it is depends upon the type of systems. One is time varying system and another one is time invariant system. The system whose parameters vary with the time. It is the time dependent. Okay, then that type of control system, it is a time varying control system. Some occasion that the system parameter does not vary with the time. Okay, it does not depends upon time. It is named as a time invariant system. So another way of classification, it is basically depends upon how many inputs and how many outputs of your control system. One is SISO and MIMO. SISO means single input, single output systems, and MIMO means multi-input, multi-output system. For SISO, that the system has single output for the single input, but in MIMO, multiple outputs for a multiple inputs. The famous classification in most of the control system is basically depends upon structure as well as the control action. One is open loop control system, OLCS, and the second one is closed loop control system. That is the basic difference between in most of the control system. It will be classified in this sector, OLCS and CLCS. So I will take the open loop control system. It is a control system where its control action only depends on input signal and does not depends on output response. You will see that if R of t is my input, it is given to a controller. The controller output is a control signal, that is U of t. It will be given to a plant, it is a system. You will get the output, it is C of t. So your controller, open loop controller means that the control system control action, it is only depends upon the input signal. It does not depends upon the output signal. Okay, so the best example is electric hand dryer. Here in the electric hand dryer, the output is hot air. Okay, you will see then hot air comes out as long as you keep your hand under the machine, irrespective of how much your hand is dry. Okay, so you don't depend on, so that the hot air will come for some particular time interval, that is in some 10 second or 20 second, whether your hand is dried or not. Okay, it is so it is a open loop control. What is the main advantage of the open loop control system means simple design and easy to construct, and then it is economical and easy for the maintenance and highly stable operation. That the disadvantage, it not accurate or reliable when input or the system parameter are variable in nature. If it is in system is variable and recalibration is required for each required in time to time. And another one is the closed loop control system. Closed loop control system means where its control action depends on both the input signal as well as the output response. You see the black diagram of the closed loop control system. Okay, so here there is a controller. Controller output is a control signal. It will be given to a plant. There is a output C of t. Your output, a part of the output is fed back to input. It is there is a feedback element and feedback signal V of t is given to your comparator. That the comparator will compare the feedback signal and input signal. So in previous case in closed open loop system, it is only depends on input. It is R of t. But here in closed loop system, your signal that the input to the controller, that is in directly given to a controller, but here that the output and input, it will be compared. It will produce the error signal. Error signal is given to a controller, but in previous case, input is directly given to a controller. What is the main advantage for the closed loop system is it is more accurate than your open loop control system. It can operate effectively where input or system parameters are variable in nature. If there is any variation, okay, it will be effectively give a output. And non-linearity effect of this system, it will be very less. There is a facility for a automation, and time to time calibration is not required for this closed loop control system. But the main disadvantage compared with the open loop system, it is difficult to construct. Complex design, difficult to construct, and then expensive compared with OLCS, complicated for maintenance because so many components are there. Less stable operation compared with the OLC. It is the basic difference between a open loop control system and closed loop control system. Here you see that first of all that the open loop control system OLCS, it is very simple and economical. You will see that in closed loop it is a complex and costly. Here in open loop control system, there is no feedback is needed. There is no feedback in open loop control system. But if you see the closed loop control system, a part of the output is fed back to input. It is a feedback. In open loop control system, it consumes less power. Basically, a closed loop control system consumes more power compared to the OLCs. Easier to construct because the less component, it is a little bit complex because of more components, inaccurate and reliable for OLCS. But compared with the OLCS, that the closed loop system is more accurate and more reliable. But the stability of the open loop control system is stable. But here the closed loop control system, that the stability is the major problem, and you will take a more care is design a stable closed loop system. And then in open loop control system, the changes in the output due to any external disturbance. If there is any external disturbance, it will occur the system. It is not corrected automatically. So there are more sensitive. If you give a small disturbance, okay, it will produce a more noise, more disturbance. But in closed loop control system, if any other external disturbance, it may be corrected automatically. So they are less sensitive to noise and other disturbance. And then it is a servo mechanism. Servo system is defined an automatic feedback control system working on error signal, giving an output as a mechanical position or velocity or acceleration. So that is the basic thing, that the servo system is one type of, it is just like a feedback system which control variable, your control variable is a mechanical load position or its time derivatives like velocity or otherwise acceleration. So it is the general block diagram for a servo system: reference position, control volume, amplifier and drive, wheels, etc. And then there is a difference between feedback control and feed forward control. You already discussed the feedback control. Okay, there is a process, there is a feedback controller, it is a set point, it will be given to a feedback controller. Why is my output? The output is feedback to input. These two, your output signal and your set point, it is the input. It will be combined, it will produce the control signal. So this is the disturbance. But here, feed forward means, here, feed forward control system send the information about the disturbance. Here, disturbance occur in the process, then only you will get the output, then the output is compared. But in feed forward control system sends the information about the disturbance to the control before it affects the process. So if the disturbance here directly given to the process, it will affect the process. But here you see, then disturbance is not affect the process before it will be go to a feed forward control. This type of control system can also be referred as a predictive. Okay, that the feedback loops take the system output into consideration, which enables the system to adjust its performance to meet the desired output response. So this is the basic difference between a feedback and feed forward. Or feed forward system in which the corrective action is taken before the disturbance affect the output. But here only the disturbance affect the output. Okay, then the output is here, you will take the control action because your output is feedback to input, and then you will take the action. Variables here in feed forward, variables are adjusted based on the prior knowledge and prediction. But here variables are adjusted only depends upon the error. That is the set point minus process variable. That is feedback signal that will be compared. Feed forward control takes corrective action before the disturbance entering into the process. Okay, it will take the affect the process. Feedback control takes corrective action only after the disturbance affect the process and generate an error. The feed forward control does not affect the stability of the system. A stable system without feed forward control would remain the stable system after it, including in the feedback control may create instability of the system. That the feed forward control has to predict the output and does not measure the output. So it is a sometimes called, it is a predictive control, but in feedback control reacts only to the process error, that the deviation between measured output value and the step point. So it is called a reactive control. That the feed forward control does not check how the adjustments of inputs worked in the process. So it is referred to a open loop control system. Okay. But in feedback control, it will measure the output and verify the adjustment result. So it is called as closed loop.